three.
Hi, Julia.
All right,
And everyone on the internet.
yeah. We're bummed that you're not here, so we just really hope that you get back before the end of the week, which is tomorrow. So come back soon. On the board here, we have the chart from yesterday where we had superpowers divided into gender by male-female choices. The question I'm asking is, where are the margins on this? We have to, we circled them. Allie, name all the numbers in the margins.
30, 20, 44, 54, 52, 200, 85, 115.
Right, these are the margins. Whenever you're given a two-way chart, sometimes the book does not give you the margins. Go ahead, before you even read the question, put the margins in. So make the totals horizontally, make them vertically, make sure they match this number so that you'll be set to answer the question. So always put the margins in, even if they aren't. Sometimes they'll give you this part and not this part. So don't let them trick you. So you need to put in the margins at the first step. All right, let's write out the definition for a marginal distribution. We're still on, no, we went on to day 3. So on day 3, I want you to actually write out the definition for a marginal distribution. We covered it yesterday. So I'm going to write it on the board so you can write it as I dictated. Marginal distribution. The marginal distribution, it's in a two-way table. I think we're picking up the sounds from the hall on our video. Sorry, Julia, it's too hot to shut the door. It is the distribution of values of one of the variables among all the individuals. Alright, that seems to make it less clear than it was before we started. Let's try to figure out what that's saying. The marginal distribution in a two-way table, it's the distribution of values of one of the variables among all the individuals. So, in other words, why does this number rank sitting in the margin? Because it's the distribution of values of one of the variable's invisibility among all of the individuals. So this is the sum of that. And the reason I put it up there, I think it's more clear what a marginal value is without seeing that definition, to tell you the truth. But if we are going to be going in the AP directions, they do ask some vocab. So I wanted you to see how that was worded. All right, that is what we're going to call a marginal distribution. All right, let's go ahead and do the other way before we leave marginal distribution. Yesterday we made a graph, or I made a graph, I don't know, did you get it down in your notes, the graph of, we did the marginal distribution of superpowers, remember that? Did you get it down? Or did you just watch it on the board?
You have a graph of percentage versus
Let me see
hands
it.
down.
Show me what you got. I forget. That's what we did toward the end. Yeah. All right. Did you get that on that day? There it is. Is that it? Yeah, that's it. All right. Let's go ahead and put that on today's notes again. So, without looking at yesterday's work, let's start there. I want you to make the marginal graph, and the marginal graph we're going to do first is the one that we did yesterday. So it's going to be the marginal graph of superpowers. So I want you to do it again on day 3, so it actually matches the information it's supposed to. I'm going to get rid of this definition, so I don't like it anyway, and actually put out something that I like. So start out, we're gonna put the powers. We're going to the marginal graph of powers. We're going to do invisibility, strength, telepathy, flying, and freeze time. And on here we're going to put percentages. And review for me how we got the percentages. So if I want the percentage of people who want to be invisible, where do I go for the numbers for this marginal graph? So Caleb, help me with the first one. What number do I take for invisibility?
It would be half of 30, so
Yeah, but you're going to actually do what over what then?
30 over 200.
All right, 30 over 200, and when you make that a percentage, we noticed it was 15%, just because mathematically that when 200 is reduced to 100, it takes half of the 30, so 15%, so 10, 20, 30, 40, 50. %. All right, do strength for me. Brandon, what two numbers will I do for strength? This is again a marginal distribution. Okay?
So you're using 20 out of 200?
Right. So that's going to be 10%. All right. Bailey, telepathy.
That's gonna be 44 out of 200.
All right. So it's 22. Allie.
That's gonna be 54 out of 200. So that's 27.
What did we decide?
25
27?
over 27.
Yeah. All right. Mine are on the board. It's not really lining up too good. All right, Elena, what about freezing time?
So it'll be 52 divided by 200.
Right. Half of 52 will give us a percentage.
So it'll be
2 into 52, 26. All right.
What was flying?
Pardon? Line 54? Oh, yeah, 27. All right. Did I get that marked right? Sort of. Anyway, this is what we came up with, and I want to emphasize that on a marginal distribution, this is a marginal distribution of superpower. So the superpower, we're going to do each superpower by itself, calculate the numbers. The numbers will always be from the margin, because we're going to leave the margin today, and that's why I'm asking you to actually redo this one. Every chart can be done in a different marginal distribution. I said it wasn't very meaningful, but I want you to understand it. So I want you to do a second chart. Now I want you to do the marginal distribution of gender. So instead of having the superpowers along this axis, we're going to have female and male along this axis, and the percentages, again, along this axis. So where do I go to get those numbers? Let's work with the female first. Are you up with me, or are you still working on the other chart?
still working.
Still working? All right, I'll pause for a minute.
So there's just only 2 bars?
Yeah, there's only 2 bars, so it's not a very exciting or meaningful chart, but I want you to see that you can go both ways for every 2-way chart in the marginal distribution. So, Elena, help me find the numbers for female that I have to calculate. This time I'm going to need a calculator, I think. Maybe not. Yeah, maybe we can divide it in half. So we're going to stay in the margin. So we want a total number of the amount of females over the total number. So what would that be?
The total number of females?
Right.
Okay, so it'll be 115 over 200.
Right, 115. So what's one, somebody help us with that,
57.5.
okay. So 115 over 200 is 57.5%. So say I put 50% here and 100% here, 57 would be about right there. All right, and Ally, help me with what numbers would I use to calculate the distribution marginally for males?
It would be 85 divided by 200,
Alright.
which would be 42.5.
All right. So not a very exciting graph here. And all it really tells you that in our survey, there were a few more females than males. That's really only not that useful of information. So this is really probably what we would do this whole exercise for, is to see this, not this. But just be aware that, and again, when you took those numbers, like Ally and Elena, when you took those numbers, were they all in the margin again?
Yeah.
They were. So I'm just kind of emphasizing that because we're going to leave the margins behind and go into a one that can be a little bit more confusing. All right, so our main topic for the rest of the day, and we'll go as far as we can on it, I think we'll be on day 3 again tomorrow, is conditional distributions. So goodbye marginal, we're going to go to conditional. So title the area where you're taking notes, conditional distributions. We'll use the same data to learn this from, so I don't have to write any more up on the board, so this will work. So let's see how. Conditional. All right, we're going to add a condition in the conditional distribution. So as much as possible, let the words define the words for you. So we're looking at conditional distribution. I'll give you the formal definition in a minute, but let's just do one. Let's calculate the conditional distribution of responses. These are responses meaning invisibility, strength, etc. Of responses. So that's superpowers basically. I'll put that, that's what they mean by responses for males. All right, what condition have I added that I haven't added before? Here, when I'm looking at the responses, I only am going to zero in on the males. Now you might say, wait a minute, we just did a chart and we had only the males. But that didn't represent their responses. Is that time to change it? All right, did you already do it?
Not yet.
Julia, we're on part 2.
Goodbye.
What is it?